Hello everybody, Miss Collin here, and I'm talking about similar figures and solving for similar figures and setting up proportions. So I'm on page 8. I'm going to do page 8 and 9 with you real quick. Okay? So they're asking, are the figures below similar? Show your work. The first thing that they give us here is a bigger triangle and then a smaller triangle, right? Now, they start asking us about the angles. And I already started to label this photo for you. I think it's very helpful to color coordinate it, like I've said in the past, because we see that angle A here is 35 degrees, and we also see a 35-degree angle in the smaller triangle XCY. Okay, so angle A is actually congruent to angle X. We can say they're congruent because they're the same measure. That's what congruent means. Angle B is 55, and so is angle Y in the smaller triangle. And then angle C is 90 degrees. These are 90 degrees, right? That's what that means, which means that angle Z is also 90 degrees. So here I have 3 angles that are congruent. Um, this doesn't tell me that the triangles are congruent. Don't mess that up, but it does tell me something about these figures possibly being similar. In order for them to be similar, all the angles must be congruent, which they are, and the sides are proportional. What does it mean to be proportional? That's where we've been setting up a proportion and seeing that they simplify to the same scale factor. Okay, so um, if the angles are congruent, the sides across from those angles should be proportional to each other. So that's where I drew these arrows for you guys, okay? So let's start with the yellow one, angle A. That means that side CB should be proportional to the side across from 35 over here, so YZ. Okay, so that's over here. I'm going to fill this in. BC is similar to, um, I'm sorry, BZ is similar to YZ. Okay, I made sure that I started with B starts with a 55-degree angle, goes to a 90-degree angle. So here I needed to start with the 55-degree angle and go to the 90-degree angle. Okay. Um, so then if I'm comparing down here, they already have me setting up a proportion for it. So I'm going to kind of jump there to really show if it's proportional or not. BC is 32, right? We see that. It's 32. I'm just going to color coordinate this in yellow. And we are comparing the bigger triangle to the smaller triangle, right? So BC is my bigger side. YZ, I'm comparing it to. And that is 20. Okay? And then I'm going to simplify that fraction, right? What do they both divide by? They both divide by 2. If I divide this by 2, that's 10. And on the top, oh, we can even go further with that, right? They are both divisible by 4. So if I divide the top by 4, I get 8. And if I divide the bottom by 4, I get 5. Okay, so 8/5 is actually going to be my scale factor, but we'll come back to that. So the next one they have up here is AB. They say AB, which is the pink one I have highlighted here, is across from my 90-degree angle. That means over here across from my 90-degree angle, and it goes from my 35 to my 55, so 35 to 55, I'm going to label it X, Y. Now, down here, they already have this kind of set up for us. Awesome. AB over XY, that's 40 over 25, which simplifies to 8/5. Okay, we're starting to see that common scale factor. That's good. If I get it with this last side here, if I get the common 8/5, all the sides are proportional, they all simplify to the same fraction, and all the angles are congruent, then I can say that these two figures are similar. All right, so I'm going to check it out. CA is the green one here, right? So it's 24, and it's across from my 55-degree angle, which means Over here, it's XZ, and is that the proper term? Let's see, for CA, I go from 90 to 35, so I need to go from 90 to 35, so it's actually ZX. Order matters, remember that. So 24 over ZX here is 15, okay? So what does this simplify to? Well, my top and my bottom are both divisible by 3. 24 divided by 3 is 8. 15 divided by 3 is 5. And to that, we have just shown that the two triangles, so triangle A, C, B, is congruent to triangle, it should say similar, I'm sorry. So it should say similar, not congruent here, so we're going to change that in a minute, but to triangle X, Z, Y. Okay? And we're going to fix that to similar. Now the scale factor, we're looking at big to small. Okay, so I have 8/5 here, but remember, big to small, the order matters. So I'm saying, what am I multiplying my big triangle by to get to the small triangle? And 8/5 would actually be an enlargement, right? So my big to small, 5/8 is what is going to make it smaller. So my scale factor is 5/8. Okay. So sometimes we have to look at the picture and decide, okay, this is just a proportion. This is not necessarily the scale factor. Depends what you're comparing. Big to small, I'm multiplying my big by the fraction to get a smaller number. This is really, 1 and 3/5. So it could be a bigger number. Okay. All right, coming down here, we're doing a similar thing. They're asking if they're similar. We have congruent angles. We need to show that the sides are proportional. So you guys can fill this information out now, but coming down here, we need to make sure that we have, I think the biggest thing is the sides here, right? So AB over WX, they already show me that AB is 28 and WX here is 35, so 28 over 35 is 4/5. I'm going to see if I get that same proportion for all of these. So I think it's important here, I gave you the answers, but maybe pause the video, go back for a second, and see if you can line up the corresponding sides. It's easier to think about this if you flip this figure over, kind of rotate it, and then you can kind of see that this is really just a smaller figure over here. Kind of flip it that way, D stays over here, and then you have these corresponding sides, okay? For ZW and YX, they're the same, so it's not, it's not terrible if you mix those up, but this is what you should get when you take a look at it, okay? So we're going to set this up, BC over XY, so BC is 12.4, and XY is 15.5. Okay, so if we simplify that, we get 4/5. Okay, now you can either put that in your calculator and you can get 12.4 divided by 15.5 is 0.8, and we know that 4/5 is 0.8, or you can do it in your calculator as a fraction. Okay, so CD, we're going to set up the same thing, CD over YZ, and we know that for CD, my side is 20, and for YZ, my side is 25, okay? So we know that these are both divisible by 5. When I divide them both by 5, I get 4/5, okay? I'm seeing the same thing again. 4/5 is a common proportion, okay? So DA is 12.4, and this is actually going to be the same as over here, right? 15.5. We know already that that simplifies to 4/5. Therefore, now we can say that these figures are similar. And once again, to change the sign down here, by the fact that all the angles are congruent and all the sides are proportional. So I can automatically set up my similarity statement here. I change this, and my scale factor is actually going to be switched again because I'm taking this smaller figure and I'm making it bigger. 4/5 would make it smaller because it's a fraction, right? 0.8, where 5/4 is 1 1/4, so it would actually make it larger. Okay. Okay, now hopefully we'll get to the point where, if we say these are similar, you'll just be able to quickly identify the scale factor. Here I set up the proportion just in case we still do need to see this. And we can set up 84/14 equals 72/12. So I'm comparing the bigger triangle to the smaller triangle, right? And I see that they're proportional, 6 = 6 = 6. But I'm getting smaller, so it's actually a scale factor of 1/6. Okay, now if that is confusing to you, hopefully you can get to the point where you can look at this and you can say, okay, I'm starting to see these corresponding sides here. I see that UV and GF are pretty similar, and I know I'm going to multiply by a bigger number because I'm going from small to big. So 18 times what will give me 42? Or 42 divided by 18 is what? Or 9 times what is 21? Okay, now this one's not as easy to see because you're like, well, Miss Cullen, that's not an easy number, right? So maybe we still want to set up a proportion here, and we're going to have to simplify these, right? So 9/21, those both divide by 3. I have 3/7, and 18/42, those both divide by 6, so I have 3/7. Sorry. 3/7. Okay, so how did I get there? Well, I'm really multiplying by 7/3 because I'm getting larger again. Okay, now what I was talking about before is where you can probably more see it here. Okay, in this triangle, in these two triangles, I clearly see that this side is corresponding to the longer side over here, right? Well, how did I get from 8 to 4? I'm already seeing it. Oh, I divided by 2 or I multiply by 1/2, right? Let's see if that's consistent. This side looks like it's corresponding to this side, and it is. They're both across from 50 degrees, okay? So 6 to 3, same thing. I multiplied by 1/2, okay? So then they're going to ask you, okay, well, what about this missing side? They're asking you to find this missing side. We're going to go back up there and find the missing side too, but they're asking you to find this missing side here. Well, what is this side? If your scale factor is 1/2, which we clearly see it is, okay? What is this missing side? Well, it corresponds to this side here, right? So what's 4 divided by 2? This should be 2 centimeters. That's my missing side. Okay, so first you have to recognize the scale factor, and then you have to find that missing side using it. Okay, so same thing up here. I don't know this other side here, but I know that this side corresponds to this side. So whatever this is, it's going to be 3 times 7/3, right? So if this is x, this is 7/3 x. Okay, so we're going to have more. We're finding missing pieces here, but it's important that you see that scale factor.